Okay, welcome back, guys. So in today's question, we have another equilibrium question in 2D, and we have a load Q that is applying to the pulley C, which can roll freely in the cable ACB. The pulley is held at the position shown by the second cable CAD, and that passes over the pulley A and supports the load P. We know that the P is 750 Newton, and we need to determine at the A part the tension in the cable ACB, and B part the magnitude of the load Q. If we look at the cable CAD, we'll see that we have one single cable going around the pulley, which has the force of P. So the tension in that cable will be, we have the force P. Okay, let's start with the free body diagram of pulley C. So as I mentioned, we have the force P, which is coming from cable CAD. We have another force, which is what we have in the cable TACB, which is one of the unknowns, and we also have same tension TACB on the right side of the pulley, and we have the force Q applying at the center of the pulley. We have the angle on the right side 25 degrees, and on the left side we have 55 degrees, and that's it. That's all the forces that we have for the free body diagram of this system, and we can move on to our equilibrium equations. Let's start with the sum of all forces in x direction. Let's see what we have. So we have TACB, cosine of 25 degrees on the right side of the pulley, and we have TACB, which is negative, this time cosine of 55 degrees, and we'll have also minus p times cosine of 55 degrees equals 0. So we know P is 750 Newton. The only unknown that we have in here will be TACB, and if we move the P cosine of 55 on the right side of the equation, and if we factor TACB, we'll have cosine of 25 degrees minus cosine of 55 degrees. From here, we can find the tension in the cable, which will be 1292.88 Newton. So that was the answer for the A part of the question, which we needed to find the tension in the cable. And the B part, we need to find the magnitude of force Q, of the load Q. We haven't used our Fy, and from the Fy, we can find the other unknown that we have in here. So this time we'll have TACB. If we factor it in here, we have this time sine of 25 degrees plus sine of 55 degrees, and also we have P times, which is 750 sine of 55 degrees, and the last force is Q equals 0. We already found TACB from the previous part, and the only unknown will be Q, which is 1219.8 Newton, and this would be the answer for the B part of the question. So what we needed to keep in mind is that we have two different cables, which each of them has a single force. So for CAD, we have the force of P, and in the TACB, we have the tension on both sides of the pulley.